This is the outline. First, I will define this task, and then I will introduce our system architecture step by step. Then I will show you some evaluation results, and at last, I will make a conclusion. So first, what's an related work section? This may be a very easy question. For we all need to write a related work section in our paper. And the purpose of related work section has two aspects. The first aspect is to help readers to understand the context of the research problem. The other aspect is to show the differences and advantages of the current work. But automatic related work section generation is a very challenging task. So first, I think we should investigate the structure of the related work section. Here is a brief version of the related work section in my paper. So we can find that this related work section provides the background knowledge of summarization, and this related work section mainly talks about two different topics. The first is scientific article summarization, and the next one is news document summarization. So actually, we can transfer this related work section into a topic tree like this. The root is a topic summarization, and below it there are two subtopics. The first one is scientific article summarization, and the next one is news document summarization. So usually related work section can contain several topics and can be transformed to a topic tree like this. In the other hand, a related work section usually has two different parts. One part usually describe the previous work, like the red color part. And besides all the background knowledge, the author often compare his own work with the previous work. The differences and advantages will be mentioned. So this example give us the intuition of the structure of the related work section. So here is the definition of the task. The input of the task is a task paper which has no related work section, and each task paper has its corresponding reference paper set, and this reference paper set provide the background information, and here we assume that the abstract and the introduction sections have been written of the target paper. This is reasonable because most of the author has already written their abstract and introduction when he wants to write his related work section. So our goal is to extract the sentences to generate the related work section. So here we can regard it as an extractive summarization problem. Here is our first step. Our input is the target paper along with its reference paper set, and the first step is pre-processing. Here we extract the texts of our paper, and the physical structure of the paper are also detected, such as section, subsection, and paragraphs. And for the reference paper, only the abstract, introduction, related work, and conclusion section are used. For other sections like the method or the evaluation result section may describe extreme details about the method or the result, and they are not suitable for our problem. And as mentioned before, only abstract and the introduction section of the target paper are used. The second step is to find the latent topic in the paper set. So recall the structure we discussed before. A related work section can be transformed to a topic tree like this, but it's certainly non-trivial to construct such a tree. So Han and Kang create this kind of topic tree in manual. So our solution is straightforward. We simplify the tree, and in our simplified tree, there only exists the parallel topics. In this case, we only need to discover the topics of scientific article summarization and the news document summarization. So we can use a basic topic model like PLC to solve this problem. In our PLC model, each sentence are treated as a document, and we apply chunking to each sentence and to extract the noun-phrases. And the noun-phrases such as sarcastic grammar or specialized grammar are treated as words. Note that the general phrases are discarded, like training data and evaluation result. Here we use TF-IDF and some rules to do this work. So now each sentence will have a topic weight in each topic. And the topic weight indicates the relevance, its relevance with the specific topic. Now we have the topic information of each sentence. So we need to know which sentence is better to be extracted. So the next step is to learn the importance score, sentence score of the sentences. Recall the structure we discussed before. The read word section has two different parts. The one part describes the previous work, and the other part discuss the author's own work. So the sentences should be extracted for the different parts can be very different, so they should be treated differently. So how to learn the sentence score? Here we use a supervised learning method, supported vector regression. To construct our training data, we split the growth-related work to two parts. The first part describes the previous works, and the second part discusses the author's work. So we compare the sentences in the sentences to the corresponding part. For that's to say, for a sentence in a target paper, we should compare it with the part that discusses the author's work. The importance score of the sentence is defined as the max similarity of this sentence between this sentence and the one sentence in the corresponding set of the sentences in the growth-related work section. So here, standard cosine similarity is used as the similarity function. So we have trained two different SVR model for the sentences in the target paper and the sentences in the reference papers, respectively. Here are some features we used in the SVR model. The first table shows the common feature used in both two SVR models, such as the similarity between sentence and each title, the part tree information, and the second table. Shows the additional feature used in the SVR model of the target paper in the SVR model for the sentence in the target paper. And the feature such as whether the sentence contains a citation or whether the sentence contains words or phrases used for comparison, and such as in contrast and or instead. So this is the whole system architecture for our system. And finally, we used an optimization framework to solve the whole problem and to generate the final network section. So what do we have now? We have two sets of sentences: the target paper set of sentences and the reference paper sentences. And for each sentence, we have their topic weight for each topic and their predicted importance score. So here is the objective function of our optimization framework. This is the main notion. I will not introduce the objective function in detail here. I will give you some intuition of this objective function. The first part of the objective function is to maximize the selected sentence score in reference paper. So our generated read work section should describe the previous work very well. So we assume that if a sentence has a higher score, it's better to be selected. The second part of the objective function is to maximize the selected sentence score in the target paper. And the last part of the objective function is consider the redundancy reduction. And the utilization is that when more Unicode diagrams the related work section has, the less redundancy the related work has. So these three parts are normalized, and lambda 1, lambda 2, and lambda 3 are parameters to tune, and their sum is equal to 1. This constraint I will not discuss here, and you can find the detail in my paper. So we can transform this optimization problem to a linear programming problem. Then we use the IBM simplex optimizer to solve this problem, and it usually takes tens of seconds to solve it, and I think it's efficient. And what we have now, we have selected sentences for both the previous work part and the own work part. And we also have sentences clusters which belong to different topics. With this, we can easily generate the final draft related work section. So our data has 1,050 target paper from the ACL Authology. each target paper had its corresponding reference paper set, and we divide the data set into 3 parts: 700 for training, 115 for test, and the other 200 for validation. We used our baseline. We used the baseline. We used med and next rank. Here we also realize here the baseline. We also implement our method and the baseline on the input without the target paper's content. We do this to validate our assumption of the structure of the related work section. The evaluation matrix is standard, and we use the ephemeral score for Rouge and the manual ratings. The Rouge is an n-gram comparison-based measure, and the manual evaluation includes 5 stars ratings on 3 perspectives. The first perspective is correctness, and the second perspective is readability, and the last perspective is usefulness. So here is the Rouge here is the result of Rouge ephemeral score. We can see that our system performs much better than the baselines, and our method and all the baselines can get an improvement when after considering the target paper's content. So the results prove our assumption of the structure of the related work section. These 3 figures show the parameter influence of Rouge score when tuning the Nematar parameters. So we can see that the 3 parts of our objective function are all useful to improve our content quality of the generated related work section. Last is the human judgment score, and the human judgment also shows that our system can perform better than the baselines. And it shows that our system's output is more related to the target paper, and in addition, our system outputs are more readable and useful for the author to prepare the final related work section. So this is a conclusion. In this paper, we proposed a novel system to generate the related work section, and a PLC model is used to split sentences into different topic-biased parts, and the supported vector regression model is used to learn the importance scores. And finally, an optimization framework is used to generate the final draft related work section. And the evaluation results show that our system can perform better than the baselines. Thank you. That's all my presentation.
Any questions? Okay, let me start with my question. Can you intuitively explain to us what your approach does that makes it better than the baselines?
Because we trained because we used a supervised learning model, and we learned the sentence score based on a large data set, and the optimization framework we used can select the global optimization results from the results. So I think our results can perform better than the baseline.
Any questions? So let me ask another question. When we try to learn the importance of a sentence, you use regression, etc. So how important is it that the training data contains the topics that you have in your target papers? In other words, is the domain, what I mean is topics, like are you trying to handle target papers on summarization or a specific topic? And if you have specific topics in your target papers, does the training data have to match the topics that you have to those in your target documents? Let's say you're trying to do the related work section on summarization. Can the training data come from this course or machine translation or some other topics? Or does the training data's topic have to match those?
I think maybe it must match the domain.
When you say domain, do you mean topics or what exactly do you mean by domain? So scientific papers can be a domain. So what do you mean exactly by domain? Topics?
Topics.
Okay. So if you're trying to generate related work sections for summarization, then the training data have to be papers on summarization. Is that what you mean?
Yes.
Other questions? Okay, so I remember that you mentioned that you use noun phrases and you remove some frequent phrases in one of the slides that you put in that slide. I think it's the slide on PLSA. When you try to learn the topics, you remove something from the sentences. Yes, like
here?
Training data evaluation result. How do you decide, which phrases are general and should be discarded?
For example, if the phrase had a low TF-IDF score, we think it's a general phrase, or the phrase has a clue word like training or data, we also think it's a general phrase.
Okay. Any other questions? So with respect to each target document, you have is that what you call it, the reference documents? Or what is it? How do you call it? Can you go to the evaluation slide here? Yes, the previous one. Okay, so you have those reference papers. How do you select those reference papers? Is there a different set of reference paper for each target paper?
We just collect all the reference papers and drop the book and the PhD thesis.
I see. So the reference, is it because you are summarizing or generating related work sections for a particular topic like summarization, and so all your reference papers will be summarization papers? Or how do you get the setup?
The reference paper is get from the citation of the target paper.
Oh, okay, I see. Other questions? Okay, let's finish.